Unit 5.2 Square Root Arithmetic Review, which is just simplifying radicals. So our objective today is that students will be able to simplify radicals. So two key vocabulary words that we need to know for this lesson, which are used interchangeably, are radical and square root. Now, to just clarify this, radical is the sign itself, and square root are anything that is under the radical sign. So the square root of 36 would be 6. So the radical is this sign by itself, and then the square root is the number that's under the radical sign. Now, the property that we need to remember is that the square root of some number ab is the same thing as the square root of a times the square root of b. Today's lesson is very short. We're going to talk about how do we simplify radicals. So to simplify, we need to use the product property rule, which is right up here, with our trusty perfect square number line. So this is one of my favorite number line. We go from 0 to 15. You can go to whatever. And then I want to write the product property on top, or the square root on top. So all I'm going to do is take the number at the bottom in blue and square them and put it on the radical. So 0 squared becomes the square root of 0, 1 squared is 1, 2 squared is 4, and so on. 8 squared is 64, 12 squared is 144. So all this is telling you is that the square root of 121 is 11. Now, there are a few steps that we need to look at when we're factoring or simplifying, a radical. So the first thing that we want to do is write the perfect square number line. You can just write it like this up here, or you can start at 0, 1, 4, 9, 16, blah, 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 all the way to, wherever is needed. So what we're going to do is start at the number given in the problem. Check each perfect square from the top of the number line until you find a factor of the given number. Write that number under a radical, and then write the other factor under its own radical, and then we're going to simplify the first one because the first one's going to be a perfect square. So let's see how this works. So the first thing I want to do is write my perfect square number line. I'm going to start with 0 and 1. You'll never use these two. So that's 0, 1, 4, 9, 16, 5 times 5 is 25, 36, 49. We'll have to go to all the way to 200, which will be a challenge, but we can do this. We know this is 7 times 7, 8 times 8, 9 times 9. Let's extend this. 10 times 10 is 100. 11 times 11. 12 times 12. 13 times 13. 14 times 14. And then 15 times 15. Alrighty, so we have our number line here. Goes from 0 to 225. The largest one we're going to need is 200. So let's look at the first example. Square root of 12. The first one we have is the square root of 12, which we know is going to be somewhere here, and I'll draw this line. We'll look at all the perfect square that are smaller than 12. So is 9 a factor of 12? How do we know if it's a factor of 12? Is by, and I'm going to make a note and then take it off. So if it's a factor of 12, this is what you do. You take 12 divided by 9, and you should get a whole number. If I do 12 divided by 9 and I hit enter on my calculator, I am going to get 4 over 3, which is not a whole number. This will not give me a whole number, so that's how I know it's a factor. Now, 9 is not a factor of 12. Good. Is 4 a factor of 12? Yes. So we know, give it radical. So square root of 4 times, what number is going to give me 12? 4 times 3 will give me 12. And again, this 3 is coming from, and I'll make a little note again, this 3 is coming from 12 divided by 4, which is 3. Now, and the last step says the first number that I wrote, which is the square root of 4, can be simplified. This is actually square root of 4 is 2 radical 3. And that's my final answer. Now let's take a look at 98. So I know 98 is going to be somewhere here. Is 81 a factor of 98? No, so that's out. Is 64 a factor of 98? Nope. And again, how do you know if it's a factor? You go ahead on your calculator and you type 98 divided by 81. You get a decimal. That means it doesn't work. 98 divided by 64. You still get a decimal. 98 divided by 49. And you shouldn't get a decimal. You actually get 2. So perfect. This works. So 98 is actually the square root of 49 times that answer that you got, which was 2. And we all know the square root of 49 is 7, and then we keep the radical 2 because that cannot be broken down. And that's my radical. Square root of 98 is actually 7 times square root of 2. Now let's look at 200. So we know it's going to be somewhere here, somewhere up. Is 196 a factor of 200? Nope. Is 169 a factor? No. Is 144 a factor? Nope. Is 121 a factor? Nope. But we know 100 is a factor, so I take that 100, write it in my radical, times 100 times 2 will give me 200. I know that the square root of 100 is 10, and then my radical 2 stays the same. And that's my final answer. Piece of cake, right? Alrighty, let's move on. Now what happens with these one when there's a number outside? Again, we're doing the same thing. So really quick, let's just write my number line again in the corner. Alrighty, so I'm going to write my number line here. 1, 0, 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and 121. I'm going to stop there because the largest, oh, I need 300 actually. 144, and we're going to stop there for now. So what I'm going to do is just like what we did, but this, you see the number that's outside? We're just going to keep it outside for now. Now 300, I know by head that is going to be 100 times 3. And this will be the largest perfect square. So I'm going to bring my -4 down times. Remember, the first number under the radical, we can find a number. So the square root of 100 is 10. And then we keep our square root of 3. -4 times 10 is -40. Square root of 3, and that's my answer simplified. 2, keep that 2, 18, and we know 18 is going to be somewhere here. Oh, look at that, the first number, it's 9. 9 times what? 9 times 2 is 18. Square root of 9 is 3, and then I have my radical 2 stays the same. 3 times 2 is 6, square root of 2. And that's going to be my final. Now look at this, keep my 10 outside. 108, I know 108 will be somewhere here. And again, what you want to do is check, is 100 a factor of 108? Nope. Is 81 a factor of 108? Nope. Is 64 a factor of 108? No. 108 divided by 49 is still not a factor. 108 divided by 36, though, is a factor. So I know this is gone, that's gone, that's gone, that's gone. I'm at 36. So I get the square root of 36. 36 times what will give me 108? 36 times 3. Excellent. The 10 comes down, times the square root of 36 is 6. And then here, this becomes 3. 10 times 6 is 60. And then this becomes, just keep it as your radical 3. And that's my final answer. So the most important thing when you're simplifying radical is writing this out and look for the start at your number. So for example, 108, we know it's between 100 and 121. So start looking for factors of everything that's smaller. Alright, so some square root properties that we need to know is that the square root of a times the square root of b, I can just simply rewrite it as a times b under one radical sign. And vice versa. If I have two numbers under a radical, I can split them up. Same goes for division. The square root of a divided by the square root of b, I can write it as the square root of a divided by b. And just in general, square root of a plus the square root of b does not equal to square root of a plus b. So these are some things to keep in mind. Our last example before you go and practice these radical is a simple question here. This is a little mixture of geometry. So it says consider the right triangle below. It has a leg of square root of 18 and square root of 32. Find a hypotenuse. So a right triangle, remember that thing you did in geometry with a squared plus b squared equals c squared. Now this is my a, that's my b, and this is my c because that's my hypotenuse. So I want to write this now. Square root of 18 squared plus square root of 32 squared has to equal to c squared. Now the square root and the square cancels off. I'm left with 18 plus 32 because these cancel off is equal to c squared. And I'm going to just write at the bottom what is 18 plus 32 is 50 is equal to c squared. To get rid of the square, I take the square root of both sides. This is cancel. And I know that square root of 50 is equal to c. But the question actually asked me for the simplest radical form. Simplest radical form. So I want to break this down. Again, I'm going to write my line 0, 1, 4, 9, 25, 36, 49, and I'm going to stop because I know it's going to be somewhere here. Is 49 a factor of 50? No. Is 36 a factor of 50? No. 25? Yes. So that's going to be my first number, square root of 25. 25 times 2 will give me 50. And then the square root of 25 is 5 times radical 2, which is my c. So my c in simplest term is going to be 5 radical 2. Now the second part of this question says, and I'm going to just draw a line here, b. And I want to move these over here. Oopsie daisy. Whoops, what's going on here today? I want to move these here over here so I can have some space. And we're going to do b. B says find a perimeter. What does perimeter means? Perimeter means the distance around. So I know that this is, as we said, 5 radical 2. So I want to break these down. So before I do that, let's go. Square root of 18 plus square root of 32 plus 5 radical 2. Let's break each of these down. 18 is actually broken down as 9 times 2 plus 32 is 16 times 2, and then I already have my 5 radical 2. So notice that we can even break these down a little further. So square root of 9 is 3 radical 2 plus square root of 16 is 4 radical 2 plus, and we already broke down my 5 radical 2. Notice all of them have radical 2, so that means we can combine them. So we know it's going to be something radical 2. And then we're going to just add. 3 plus 4 is 7. 7 plus 5 is 12. So the perimeter is 12 radical 2. And that's how we apply our simplifying radicals. This is a very, very, very extremely important lesson because a lot of things on the regions ask you to write it in simplest radical form. So you know what to go and do. Practice, practice, and remember, practice makes perfect.